Welcome, detectives, to our explainer on AI Fundamentals, Evidence Discussion Video Overview. Today, we're going to investigate how to critically evaluate claims about artificial intelligence. In a digital world where AI is constantly generating answers for us, it's absolutely crucial that we learn how to look under the hood and separate fact from fiction. Because, well, whether an AI is recommending a video for you to watch or physically driving a car down your street, we need to know exactly why we should or shouldn't trust it.
So let's kick things off with a massive question. Just because an AI gives a perfectly plausible explanation, does that mean it's actually provided hard evidence? You know, it's incredibly easy to look at a highly confident, instantly generated response from a machine and just assume it's the absolute truth. But as we'll discover by interrogating the data and logic behind these systems, an output is really just an output. It is not automatically proof of anything.
To solve this mystery, we're going to follow a quick 4-step roadmap today. We'll start by tackling some common misconceptions, then unpack what AI evidence actually is, apply a solid reasoning framework to a real claim, and finally, transfer your new skills to a brand new case. All right, let's dive straight into phase 1 and bust some of the most common myths out there about AI systems.
Before we can properly evaluate evidence, we really have to clear away the unsupported generalizations that kind of cloud our judgment. There's this massive contrast between the myth that all AI wants the exact same thing versus the reality that AI systems are highly specific. You'll often hear broad statements about what AI wants or what it does as if it's just one single giant entity. But actually, an AI system uses very specific inputs to achieve very specific objectives. I mean, a system designed to score your credit is fundamentally different from a system designed to play a video game, right?
And that brings us to the golden rule for today. A plausible explanation is not the same as evidence. Just because a chatbot generates a highly confident, totally reasonable-sounding essay, that output alone isn't proof that the facts are actually true. A plausible explanation is just that, plausible. Real evidence requires us to dig way deeper into the actual data and the models used to arrive at that explanation in the first place.
So how do we find that actual proof? Let's move right into phase 2 and look at how the OECD defines what is really happening under the hood. According to the OECD, an AI system is actually a highly structured mechanical loop made up of 3 key elements. First, sensors collect raw data inputs from the environment. Second, operational logic interprets that data based on a given set of objectives. And third, actuators actually produce an output or change the environment based on that interpretation. Think of it like this. A camera acts as the sensor to see the road, the operational logic identifies a stop sign, and the actuators actually press the brakes.
The absolutely crucial point here is that we cannot treat AI like a human brain. It doesn't think, it doesn't understand, and it certainly doesn't feel. It simply processes historical data using machine-based inputs like raw camera footage and human-based inputs like established driving rules to find patterns or deduce trends. We have to strip away all those human characteristics if we want to objectively evaluate the evidence an AI provides.
If you want to know if an AI's output is trustworthy, you have to look directly at the operational logic. This is the engine of the whole system. The operational logic is the core model that connects all those raw inputs to the final recommendations, predictions, or decisions. It's literally where the true power of the system resides.
Okay, now we're completely ready for phase 3. Let's step into the interrogation room and put a specific AI claim to the test.
You might actually remember the CER, or Claim, Evidence, Reasoning Framework, from your science classes. Well, we're going to use it right now to sort our evidence carefully. This means we take a specific claim, we look at the exact data and models serving as our evidence, and then we explain the reasoning. We figure out the precise relationship that connects that raw data to the final output.
Let's look at a source-backed claim from the OECD regarding an autonomous driving system navigating safely. The claim here is that the vehicle can get from point A to point B without crashing into anything. Sounds great, right? But how does it actually accomplish that in the real world? Let's sort the evidence to find out. When we break this down, we see exactly how historical data and human driving rules act as our machine and human-based inputs. The operational logic takes these inputs and uses them to predict whether an object in the road is an obstacle or a traffic instruction. Finally, the actuators output mechanical decisions, like accelerating or braking. It's a clear mathematical relationship.
But to truly evaluate this claim, we've got to stop and ask a critical question. What data might be missing here? Where is the uncertainty in this logic?
The National Institute of Standards and Technology, or NIST, actually developed an entire AI risk management framework focused on managing these exact kinds of risks. Because listen, just because the model works perfectly on paper doesn't mean it's free of risk out in the real world.
For example, a major limitation is that if the historical data only includes sunny conditions, the system's operational logic might completely fail to safely predict obstacles in a snowstorm. The AI doesn't have the common sense to just know what snow is. It only knows its exact training data. That is a massive uncertainty. If the evidence, meaning the historical data, is limited, then the claim of safe driving is seriously compromised.
Let's move to our final phase, Phase 4, and see how this framework builds your ability to investigate an entirely different type of AI output.
Once you understand this framework, you can apply it absolutely anywhere. Let's apply our evidence check to a brand new context from the OECD, a credit scoring system. Think about buying your first car or a house down the road. An AI credit scoring system outputs a recommendation to a bank to either approve or deny your loan. This is a high-stakes scenario that impacts people's actual financial lives every single day.
Just like the self-driving car, we need to identify the specific inputs and rules going into the model. But this time, you are the data. Your borrower history and human banking rules are the inputs. The operational logic interprets your data against its set objective of minimizing financial risk, which then produces the final recommendation, your credit score. The operational logic is quite literally judging your financial risk.
To ensure trustworthiness and manage risk, exactly like frameworks like NIST recommend, you now have the ultimate toolkit. You just need to follow these 5 exact steps. To check the AI's work, identify the evidence, explain the logic's pattern, identify the output, name the limitation, and finally, apply a human evidence check.
And that human check is absolutely vital. A critical limitation here might be flawed historical data. If past loan data contains hidden errors or outdated financial rules, the AI is just going to blindly repeat those same flawed patterns. It doesn't know any better. So we have to state a clear human check. We need to verify that the borrower data inputs are actually accurate and free from unmanaged risks before we ever trust that loan recommendation output.
So, as you navigate this digital world, remember that you have the tools and the power to look past the shiny output and question the operational logic and data behind every single claim. Don't just accept a plausible explanation as proof. Dig into the sensors, the operational logic, and the limitations. Ask yourself, what is the data really showing? That wraps up our investigation for today.
Unit 05, Lesson 03, AI Fundamentals, Evidence Discussion Video Overview.